Hello everyone, welcome to Gate Academy Global. So this is the first time when I am coming live in this channel, Gate Academy Global. So here we are going to cover the communication system, all syllabus, complete syllabus of communication system with the help of questions. Through questions we will solve all the chapters. So what are the chapters I am going to cover in this particular series that you have to know first, because this is the first time I am coming in this Gate Academy Global. So what are the different chapters we are going to cover, that first we will see, and then we will come to the questions. So let's see how many students have come. So Laksh, Goyal, hello. Amir, good evening. So we are having a few students right now. So let's wait for a few seconds, then we will come to the questions, and before that we will cover the complete syllabus. So right now I am not looking forward for the upcoming exams. This is for the GATE 21 and the ESE 21. So what are the different topics that you should prepare, and what are the different chapters that which is required to clear the GATE 21 and the ESE 21, that we will cover in this session. Thank you, Gyanendra. Good evening everyone. So in this particular series, yes, ESE 21 will also be covered, and I will see what are the different topics which is left in the GATE, and then that topic will be covered here in the live session. Okay, so in the starting we are covering the complete syllabus with the help of questions, and later on I will come to the theoretical part also, and which is required in ESE 21 mainly. So first please start with the random variable. So I have actually I am starting from the random variable itself, so it is good for you because you are expecting the random variable first. Because I will start from the basics, so that's why I will start from the random variable, because this is required in both type of communication, that is analog communication and digital communication. Sir, is it compulsory to solve the SHORM series for communication? Not compulsory, and no book is compulsory. If you require to practice, if you need to practice, then you can follow that textbooks. The SHORM series is a very good book for the analog and digital communication. So you should actually prepare, you should actually solve the SHORM series for every subject, in fact, because for each subject we are having that SHORM series, and there are a number of problems given in the book, and that can be solved. BARC series, there is nothing like the BARC series, especially because whatever you have prepared for the GATE, that is sufficient for the BARC itself. So only one line questions we have to do, and that will not be that much beneficial for you guys. So that's why we are not looking forward for particularly for the BARC exam. So this is the series that will be helpful even in BARC. It's not like that the question will not, the concept we will discuss, that will not be helpful for the BARC or any other exam. It will be definitely helpful for you, but I am not naming it that the BARC series. That is only a GATE 21 and ESE 21. So thank you, Laksh. So let's see first what are the different chapters I am going to cover. So first of all, I will cover the random variable and random process. So I am starting from the basic. So what are the different chapters that I am going to cover? I am writing here. So second one is the amplitude modulation. Amplitude modulation and super heterodyne receiver. And the third one would be angle modulation, and the fourth one would be baseband communication, that is the starting of the digital communication, and the fifth chapter would be band pass communication, or in fact I should write the transmission, baseband transmission and band pass transmission. And the sixth one is noise in digital communication. And the seventh one is information theory. Okay, so these are the chapters that will be covered with the help of question first, then I will see how is the response of you guys, and according to that what are the different theoretical topics which you require to learn, that will be covered. But in the beginning I am starting from the random variable and all other chapters with the help of questions only. Okay, so we will start from the random variable and random process, and that are the basic questions that I am covering. It may be possible the next series would be also on the random variable and random process, and that would be a tough questions. But because in the recently we are going to have upcoming exams like BARC and other exams that are RIML, I guess. So these competitive exams are having a one line questions, so that's why I am thinking that let's cover all the chapters with the help of questions, and then we will come back to the chapter 1 again with some moderate type of question or the tough questions. Okay. Sir, please do something for ESE specific only. GATE Academy practice book is enough or not? See, GATE Academy practice book is enough, and you have to appear the different test series, and then that would be the sufficient for the GATE exam. And any WhatsApp group, I have made one group in Telegram for communication and EMT. So in that group you can directly connect with me and you can post your doubt in that group. So noise in analog communication is not important for GATE, but it is important, not important, but it comes in ESE. So in the end of the year, around October or maybe September, we will cover that part also, because primarily we are focusing on these chapters, and I told you that what are the different topics which will be left specifically for ESE, that will be covered in the later of this year. Yes, question, when you solve the questions more and more, that will be the very good practice for you. And Gyanendra is asking about the group name. So the group name is communication, EMT and communication, and in bracket GA, that is for GATE Academy. Okay, so the group name I am writing here in Telegram. So you can join and connect with me. EMT and communication, and in the bracket that is GA, that is for GATE Academy. Okay. So shall we start with the question? Are you ready with the pen and paper? So that, and if you have not subscribed in this channel, then please subscribe in this channel, because now I will come live on this channel only. For EMT and communication both, I will come live on this channel. EMT series will also be started very soon. So we will see after that communication, I will start with EMT also, and maybe alternatively EMT communication like that. So are you all ready for the question? Diploma student, what do you mean by diploma student? Are you asking for, is it beneficial for diploma student or not? Okay, so students are replying that they are ready for the questions. So, so test series, which book is good for the test series? Every test series is good. I will not say that any test series is bad, because if you want to prepare and if you want to practice, then you can join any test series. At least 2 to 3 test series you can join. We are the GATE Academy has its own test series, so you can join GATE Academy, and the other top institutes which you are familiar with, you can join that test series also. There is nothing like that the minimum number of tests that you should appear, because the tests are like for your practice. So there is no minimum cutoff for test, number of tests that you should appear. If you can appear many tests like 100, 200, that is very good, because it is nothing but your practice to solve the questions. So let's solve the questions. First question that will be on your screen now. Which subject is good for starting preparation? Obviously, the basic subjects are network and control system that you can start with, because these subjects are quite interesting and very easy to understand, and you will get the confidence when you start with these subjects. And if you want to prepare for the communication, then you have to prepare first signal, then you can jump to the communication, because that communication requires basic knowledge of signal. So that would be helpful for you if you start with the signal. Before communication, you have to prepare signal first, because there are many concepts of Fourier transform, etc. So we are having the question number 1, and that question is a random variable x has x bar equal to 0 and sigma x square equal to 1, form a new random variable y is equal to 2x plus 1. The value of y bar and sigma y square are. So we are having the first option. Answer Abhishek, Advait and Manish all are getting the answer as C. So let's see what others are thinking. So only 3 students are replying, and the Ketan also getting the answer as option C. So one answer I am getting is option A. Mean is 0 and the variance is 1. Variance into 2. Variance into 2. Sorry. Electrical EMFT will be, that would be mentioned in the thumbnail itself. If it is mentioned EEEC, then and the EMT series EEEC, then you understand that that is for the electrical also. Okay, so if it is mentioned in the EMT series only EC, then you understand, you get that that is for only for the EC. Okay, Suman, I will mention in the thumbnail EE and EC both if it is for electrical. Okay, so let's solve this question. That is a very basic question. As I told you that today we are going to solve some basic questions from the random variable and random process. And the first question that we are having, the mean is 0, mean is given as 0 and the variance is 1. So for a random variable y is equal to 2x plus 1, so y is equal to 2x plus 1. If you want to calculate the mean, so that is expected value of y is equal to expected value of 2x plus 1, and it can also be written as expected value of 2x plus expected value of 1, because The expectation is an integration operation, and integration is a linear operation, so it can be applied in the individual term. So expectation can be applied to 2x, and expectation can also be applied in 1. Now we also know from the property of the mean that if we calculate the mean of any constant, so it results the constant itself. So the 2 is outside this expectation, and this become expectation of x plus expectation of 1, that is a constant, is nothing but the constant itself, and the expectation of x is 0, so it is 2 into 0 plus 1. So we are getting the mean of y as 1. Now we have to calculate the variance. So for variance we have to calculate the mean square value first. So mean square value of this is 2x plus 1 whole square, and it can be written as expectation of 4x square plus 4x plus 1. Again we can apply the expectation in the individual term. So we will get expectation of 4x square plus expectation of 4x plus expectation of 1. So expectation of 4x square, this is 4 times of expected value of x square, and this is 4 times of expected value of x, and this is 1. Okay, because the mean value of the constant is constant itself. So because the mean value of x is 0, so this is 0 and this is 1. Now mean square value of x, since we know that the variance sigma x square is equal to mean square value minus mean whole square. So because the mean is 0, mean of x is 0, so the variance and the mean square value of x are same. So now the expected value of x square denotes the mean square value of x. So mean square value of x, if the mean is 0, is equal to the variance, and the variance of x is given as 1. So this is 4 into 1, so we will get the value as 5. Okay, so this is the mean square value, and as from this formula the variance is equal to mean square value minus mean whole square, we have to calculate the variance of y. So the sigma y square is equal to mean square value of y minus mean of y whole square, and mean square value of y is 5 and the mean value is 1, so we will get 4. 5 minus 1 is 4. So we are having 1 and 4. So according to the option, the correct answer for this question is option C. Okay. How much portion it cover out of 100? Which portion you are talking about? I am not getting. Are you talking about the random variable and random process itself? Mayank, how much portion it is cover out of 100? If you are talking about the chapter random variable and random process, so definitely you will get 2 questions from this particular chapter in GATE 21. Okay, so everyone has got the answer. So there are 2 students, those are giving the answer like A and D. Vineet were also getting the option D, and Manku is also getting the option A. So have you got the answer now? Okay. See, if you are coming because you have not studied the random variable right now, so like start random variable with theory. Okay. See, I will come to the theory also, but here first time we are covering all these chapters with the help of questions. So if you have not studied the these chapters, or you have not studied this subject, and for that you have to wait for some time, or you have to prepare by your own, and then you can join to this series, because right now I am looking for I am covering these chapters with the help of questions, because the theoretical part is more. So I cannot cover everything in this particular session, okay, because we are having 1 or 2 hours session and we have to solve many questions. So if this series comes, so you prepare with that particular chapter and then come to the session. As I told you that I am going to cover these chapters, so this is the first series, so I am covering this chapter, and after that I will cover this. So this is today's topic, random variable and random process. So in the next session I will come to the amplitude modulation. So in the next session, whenever it will come, you start with preparing the amplitude modulation and then come to the live session. Okay. So because there is many more things that I have to explain if you want me to explain the theory, so I cannot cover everything here right now. Okay, so Rohit and Ariba, sorry for that. So next, let's solve the question number 2. So question number 2 will be showing on your screen. I will come with the theory also. Okay, so try to understand the things which I am explaining here, because these are the simple questions that I am covering today. So it's not like that you will not get anything from this session. If you will stay with the complete session, you will come to know many concepts which will be helpful for you when you will be studying that particular chapter. So while you will be studying, you will get these concepts and you can relate these two things. So that's why this session is also important. But yes, I am not able to cover here the theoretical topics. So question number 2, Sanidhya Saxena is getting answer A. Answer A is 0.25. Ketan is getting 0.75. So CDF is given for the random variable x, and it is given as this is the value k, and this is 1, and it is equal to 1 by 2. So option A, the two students are getting option A, and Ketan is getting option C, 0.75. Yes, NPTEL lectures are good for GATE, but there are selective lectures that is good for GATE. There are many lectures which is not that much useful, so you have to select what are the different lectures that is useful. So according to the topics, you search on that NPTEL lectures and then you can watch that. It's not like you have to go through the complete series of that NPTEL lecture. There are only few lectures which is useful for you. So we are having the different answers like A, C, B, both we are getting, and option C is also there. So but the many students are getting option C, and Soumik Banerjee is getting option B. So first of all, what is the value of k? Can you answer this question? What is the value of k? The value of k? Come on, reply. The value of k is 1. Why it is 1, Ketan? Because we know that from the property of CDF, the f of infinity is equal to 1. This is the property of CDF. Fx of infinity is always equal to 1, and there is another property, fx of minus infinity is 0. Okay, So if this is a valid CDF, then only we can apply its property, and this is valid CDF because it is satisfying the property of CDF, and that is at infinity it is should be 1, because if it is valid CDF then it should follow this property. So to get this value of k, we are having fx of infinity here. At infinity somewhere here, suppose the value is k, so according to this property fx of infinity should be 1, hence the value of k is 1. So you have got the value that is 1. Now we have to calculate the probability that random variable x greater than 0.5 and less than equal to 1. So from the property of CDF again, we know that this is equal to fx of 1 minus fx of 0.5. Okay. So fx of 1 we can directly calculate in the at x equal to 1. At x equal to 1 we are having this value of CDF because there is a abrupt jump. So in the finite value, because in the 1 we are having the value as k, and at 0.5 somewhere here, if you want to calculate the value of CDF, then you have to write the equation of this CDF. So what is the equation of this CDF? So if I apply y is equal to mx plus c, then the y is fx of x, and the slope is this height, which is 1 by 2, and the base is 1. So this is slope is 1 by 2 itself, and x. So and the intersection with the y-axis is at 0. So we are having fx of x equal to x by 2. Now I want to calculate the value of CDF at 0.5. So at 0.5 we will get 1 by 4, that is 1 by 2 divided by 2, 1 by 4. So now when I substitute the value here, this is the value fx of 1, that is nothing but k, minus fx of 0.5 we have calculated as 1 by 4, and it is 1 minus 1 by 4, so we will get 0.75, that is 3 by 4. Okay. So the correct answer for this question is option C, 0.75. Now if I ask that in the same question, if I ask that, please show the question again. Suppose I want to calculate probability that x equal to 1. What is the value of probability at x equal to 1? Mayank is saying that he is preparing for GATE for the self preparing, and but is not getting whether it is correct or not. So in which city you are living, and I think that you should follow some notes, or you can say some course like we are having the GATE Academy pen drive course. So you can purchase that, because that is the guideline for you, then how to prepare. So Manish and Abhishek are saying that the probability at x equal to 1 is 0. Let me send you that Telegram link. Okay. So we are having that link. I am not able to type here. Okay. Yeah. So this is the link in which I am connecting with the students for the communication and EMT. Can you see this link? the k is 1, because of the property of the CDF. You can note it down. The property of CDF is fx of infinity is equal to 1. That is why the value of k is 1. Mayank, you are saying that you are not able to afford this course, because for that what you can do is you can wait for some discount, and or you can apply for some special request to the GIT Academy team, and maybe they are able to help you, because we are having a discount right now. There is a holy discount, and there is when the launching discount, so that time you should buy, because that time the course cost is very less. So you can join that time, or you can follow any notes. If you can arrange notes, handwritten notes from for some coaching, then you can follow that, and you can prepare with the help of textbooks. So there will be more discount later on, so you can wait for that. And the Telegram link I am actually posting, but it is not. I don't know why it is not coming into the chat box. I have asked them, so they will send you the link. Okay. So now coming back to the question, at x equal to 1, probability at x equal to 1 is probability at x equal to 1 whenever there is a discontinuity in the CDF. Because the CDF is continuous, and now it is having the discontinuity, and if it is asked at the point where the discontinuity in CDF occurs, then the probability at that particular point is the difference between these two, difference between, or you can say the height of that step. Okay, so the height is this height. There is a discontinuity from this point to this point, so this height is nothing but k minus 1 by 2, the value of k is 1, so we are having 0.5. So the probability at x equal to 1 is 0.5. Whenever there will be a discontinuity in the CDF, then the probability at that particular point is the difference between the maximum to the minimum value. So are we not able to post that Telegram link? Okay. So it will be coming in the chat box. You can wait for that. So you got the answer, probability at x equal to 1. Okay. So this is the Telegram link where you can join for the communication and EMT doubts. Whatever the doubts coming in your mind for the regarding the preparation, regarding the GATE 21, and whatever you want to discuss with me, you can post there your doubt there. Okay. So now next is question number 3. So question number 3 is, an output of a communication channel is a random variable V with the probability density function as shown in figure. The mean square value of V is. Okay. So you can solve. I am giving you 2 to 3 minutes for this question. So this is the basic chapters, and what we are doing right now is a basic mathematics also. Okay, because this random variable part comes in mathematics, and now we are calculating the mean or the mean square value or the probability. So this all comes in mathematics. We have not actually coming to the communication part right now. Okay, so but after 2 to 3 questions we will go to that part also. Actually it comes in communication as well as maths, so you can consider in both. So the answer he is getting is 32, and Vishwanathan is also getting 32, Manku is also getting 32. So 2 students have got the answer 32. 328 or 32, Abhishek? Is it 32 or 328? 32, okay, okay. So all are getting 32, right? So can we discuss the question? Okay, Atul, okay. So there are more participants, we can wait for them also. So you guys have read the options properly or not? So directly you are going to solve this question without looking for the options. Whenever you read the question, always read option also, because you will maybe get some idea when you look the options. So we are having the different answers. 32, most of them are getting 32, and now the one first another answer, different answer, that is option A. So what are the different options we are having? Options are 4, 32 and 8, and see, there is a interesting option. Option D cannot be calculated. Why it is given in the option? That is the importance of the looking. When you look the options carefully, then there will be some interesting options. If it is mentioned like this, then you have to be very much careful while solving the question, because it may be, there may be some trick, because of that you may not be able to calculate. Okay, so now the answers are changing. Why it is so? Previously he said 32, but now see, now the everyone is getting, what is the point here? So now you are getting, right? So whenever, that's why I changed the question actually, because the question is from the gate itself, but there is a valid PDF in the gate, but I changed this question, and I just changed in such a way that that is not itself become a valid PDF. So we know that the area under PDF is always equal to 1. If the area under the PDF is not equal to 1, then it is not a valid PDF. Area under PDF is always equal to 1. Okay, so if it is not 1, then the PDF is not valid. So if the PDF is not valid, then we cannot apply any characteristics on that PDF, like we cannot calculate the mean square value, variance for that particular PDF. Okay, so yes, these kind of mistakes only happen in exam, so definitely this is going to happen in exam, so that's why we are preparing for that. So we are mentally ready for this type of options. So whenever this type of option comes in the exam, so always check the question first, read the question properly, then apply the concept. There is a possibility that you will get the valid PDF and you will get the answer. So but for that you have to check whether it is a valid PDF or not. So if I want to calculate the mean square value as it is asked in the question, so I am writing thus the formula, because if randomly I will solve for the mean square value, what I will get. So if I solve it for expected value of v square, the formula is minus infinity to infinity v square, and the PDF p of v, this is the PDF and dv. So according to the question, if you solve, if it is valid, if it is not a valid PDF and you solve, you will get the answer as 32. But this is the formula for the mean square value, and we will not be able to apply this formula in this particular question because the area is not equal to 1. So the correct answer would be option D. Okay. So correct answer, since given PDF is not valid PDF, correct answer would be D. Okay. Okay, let's solve the next question. Question number 4. Question number 4 is a bit a theoretical question. See, definitely I can make videos on waveguide, antenna, whatever it is. You know that I am the faculty of the communication in EMT, but you should understand that everything we cannot provide right now. There are different courses we are having, that is the pen drive course, tablet course, whatever you want. I will post important topics for that particular chapter, but everything we cannot cover in these sessions, and I am really sorry for that. So, this is a very basic question I am asking in the 4th one is that what are the different application of different random variables, and I am getting the answer as D, and all of them are answering the option as D. So, the Gaussian distribution, Rayleigh distribution, Poisson distribution, uniform distribution. So, the Gaussian distribution, if I talk about the Poisson distribution, so the Poisson distribution is actually useful for the number of calls. There are repetitive, when there are different numbers, large numbers, then we use the Poisson distribution. So, calls on a telephone channel, and uniform distribution, that is for random number, and the Gaussian distribution is thermal noise, and Rayleigh distribution is fading channel in wireless communication. So, in the wireless communication we use this Rayleigh distribution. So, according to that, if you will see, the correct answer would be option D. Okay, option D would be the correct answer. Just you can there is nothing like some theory behind this concept, so you have to remember these things. So, this type of question may ask to you, and you have to know what are the different random variables you are studying. Like you are studying the Cauchy's random variable, if you are studying the exponential random variable, then search for their application and note that theoretical point on your notebook. Because if I talk about the exponential random variable, so the exponential random variable is useful to measure the raindrop size, and now you will see there is nothing we can implement that, but we have to know, because this type of question has been asked in different PSUs where you should know about their application. Just this is a theoretical question. Rayleigh distribution is for wireless fading, thermal noise, Gaussian distribution, and uniformly distributed random variable is useful in quantization. Okay, and that is the random number written here, and the Poisson distribution where the number of calls and many numbers are there, like telephone calls. Okay, and when you have to measure the raindrop size, then that is useful with the help of the exponential random variable. So, there are different application for the different random variable. So, whatever random variable you are studying, search for their application and note on your notebook. So, let us solve question number 5. Question number 5 is, let the random variable x represent the number of times a fair coin needs to be tossed till the 2 consecutive head appear for the first time. The expectation of x is. Question number 5, random variable x represent the number of times random variable is representing the number of times you are tossing a coin till the two consecutive head appears for the first time. Okay, so if I say that if I am tossing a coin first time, I will get head, and because only getting the head for the first time is not our outcome. Our desired outcome is two consecutive heads should appear. So for that I have to toss the coin 2 times, minimum 2 times I have to toss the coin to get the two consecutive head. It is possible that when I toss the coin I will get head, and again in the second time if I toss the coin I will get head. So that will be our desired outcome. Okay, so our desired outcomes are head head. This is the minimum toss that we have to do, and the random variable x is the number of times you are tossing a coin. So to get the head and head you are tossing a coin 2 times. So that is the value of that random variable. Now suppose I am tossing a coin first time and I am getting the tail, and in the second time I am getting head, and again I am getting head. So for this outcome I have to toss the coin minimum 3 times. So that would become the number of value of random variable. Now if I toss the coin in the starting 2 times I am getting the tail and then head and head, then it would be the minimum number of toss, that is 4. Now the question is it we are not considering that part like head, tail, head and head. Okay, so that is also the number of time 4 times we are tossing a coin. Okay, so both are the same thing because our outcome is 2 consecutive head. So by in any way we are getting the 2 consecutive head, that will be considered, and now in the next time we will jump to the 5 toss, because in the 4 toss I can get the 2 consecutive head in this way. I can get the 2 tail and then head head, or I can get the head tail and again head head. So in any way if I will get the 2 consecutive head I have to stop, and now I should look forward for the 5 times. Now that is the tossing coin 5 times. Okay, so I can get the tail, tail, tail and head, head, and there are many other possibility for these 3 positions, but the 2 consecutive heads should appear. So there is also possibility like you can get the head, tail and then head and head. So this can also be considered, but that will come for the minimum 5 number of tosses. So there are infinite possibilities. So the value of these random variables are 2, 3, 4, 5 and so on. So what is the probability of getting head and head? So if I toss a coin I will get head with the probability 1/2, and these 2 events are independent to each other, because if you are tossing a coin first time a head is coming and you are tossing a second time, it does not depend on the previous toss. So that's why these 2 events are independent to each other. So the probability will be 1/2 multiplied with 1/2, that will become 1/2 square, and this will become 1/2 cube, and this will be 1/2 to the power 4 and so on. Now I have to calculate the mean value. So the mean value is expected value of x. It is equal to summation over I, and this is xi probability of xi. Now because these are the discrete terms, so we are having 2 into 1/2 whole square plus 3 into 1/2 whole cube plus 4 into 1/2 to the power 4 and so on. Now this is what you can see, that this is 2, 3, 4 and this is nothing but a series of AP arithmetic series, and 1/2 square, 1/2 cube, 1/2 to the power 4. So we can see that this is nothing but GP. So this is AGP, arithmetic geometric series, so arithmetic geometric progression. So the summation of alpha n into alpha to the power n, that is n from 1 to infinite, is nothing but 1 upon 1 minus alpha whole square, or it is alpha upon 1 minus alpha whole square. Okay. So, if you expand it, you will get 1 into alpha plus 2 into alpha square plus 3 into alpha cube, and the summation of this series is alpha upon 1 minus alpha whole square. Now, so it should start from 1 into alpha. So, alpha is the common ratio of GP. So, here we can see that the common ratio is 1 by 2. So, it should start from 1 into 1 by 2, because the alpha is 1 by 2. So, it should start from 1 into 1 by 2. So, for that what we will do is we will multiply 1 by 2 both the side. So, or actually I have to add and subtract 1 by 2 both the side. So, let us add it. So, 1 by 2 and 2 into 1 by 2 square and 3 into 1 by 2 whole cube and so on, and let us subtract minus 1 by 2. Okay. So, now the summation is 1 by 2 and 1 minus 1 by 2 whole square minus 0.5. So, how much we will get? It is 1 by 4 and 1 minus 1 by 2 is 1 by 4. So, this is 1 by 2 and this is 1 by 4 minus 0.5, and you will get 2 minus 0.5, which is equal to 1.5. Okay. So, the correct answer for this question will be 1.5. So, many of them are answering 1.5. So, not getting the question, Shubham. Have you got the question now? The question is the minimum number of toss to get the 2 consecutive head. So, 2 consecutive head you should get, and to get the 2 consecutive head you have to toss the coin minimum 2 times, and how many number of toss you are tossing the coin, that will become the value of random variable. Okay. So, you are tossing the coin 2 times. So, the number of random the value of random variable is 2, and if you are tossing the coin 3 times, so then value of random variable will become 3 and so on. Okay. So, next question number 6. Next is question number 6. Let u and v be the 2 independent zero mean Gaussian random variable of variances 1 by 4 and 1 by 9 respectively. The variance of 3v minus 2u is. So, Ketan is getting the answer as option B, option D, that is 2. Okay, so yes, Ketan, you are right, because the answer is 2, because these are the 2 independent random variables. So, this 3v minus 2u, and u and v both are independent random variables. So we know that from the property of variance, expected value of x plus minus y, if the x and y are two independent random variables, the variance of x plus y is variance of x plus variance of y if x and y are independent. Okay. So if the random variables are independent, then the sum of the random variable or the difference of the random variable is equal to the variance of individual random variable. So what is the variance of this v? So the variance of v, if you will calculate, so because the mean value of u and v both are 0, so let's write, we know that the variance is equal to mean square value minus mean whole square. So if the mean is 0 for any random variable, if it is 0, then the mean square value become the variance. Okay. So what is the variance of v? So the variance of v is nothing but mean square value of v, and the mean square value of v is 1/9, and expected value of u square, this is sigma u square, is equal to 1/4. And also we are having the property that variance of c into x is nothing but c square into variance of x. Variance of any constant multiplied with the random variable is equal to the constant square and the variance of x. So similarly, if I want to calculate the variance of 3v minus 2u, then it is 3 square variance of v plus 2 square variance of u. So this is 9 into 1/9 plus 4 into 1/4, and it is equal to 2. This will get cancelled and we get 1 plus 1, which is 2. So the variance of 3v minus 2u is 2. So the correct answer would be option D. Okay. So next is question number 7. So total we have to solve the 15 questions. Okay, so we are right now at 7 questions, so let's do it a bit fast. Question number 7 is showing on your screen. Let x and y be two statistically independent random variable uniformly distributed in the range -1 to 1 and -3, 1 respectively. Let the z equal to x plus y, then the probability z greater than equal to 0 is. Question number 7, let x and y are two statistically independent random variable. So here we know that if the two random variables, those are statistically independent, are added together, if they are added together to form another random variable like say z, which is the sum of these two random variables, and these two random variables are independent, then the density function of the sum of these two random variable is nothing but the convolution of density function of individual random variable. So fx of x and fy of y you can write. So the density function of this output random variable is the convolution of individual PDF. So here it is given that these two are uniformly distributed between -1 to 1 So the height will be 1 by 2. Convolve with -3 to 1. So that will be 1 by 4. How the height is 1 by 2 or 1 by 4? Because the area should be 1, as we have discussed. So the answer is 1 by 4 Ketan is getting. So let's see, if I draw the PDF of, if I draw the convolution of their PDF. So because this is the two unsymmetrical rectangular pulse, so the convolution of this two rectangular pulse is trapezoidal, and to get the value of trapezoidal, if we add this minimum value -1 and -3, I will get -4, and the maximum value of the trapezoidal is 1 plus 1. If I add these two, 1 plus 1 is 2, so I will get 2 here. Okay, and the trapezoidal is having shape like this. Okay, so there is 2 points where the slope is changing. So these 2 points are the intermediate value. That means you have to take the minimum value of first and maximum value of second. So if I am taking the minimum value of first and the maximum value of second, so -1 plus 1, that is 0, that is another point, and there should be 2 points where the slope is changing. So for that you have to take the maximum value of first and minimum value of second. So the maximum value of first is 1 and minimum value is 3. If I add these two, I will get -2. So -2 will lie somewhere here. So these are the 2 points where the slope will be changing. So if I draw the trapezoid, so it will look like this: -4, -2, 0 and 2. So these are the 2 points where the slope is changing. And what is the value of this slope? The value of this slope is nothing but the multiplication of height of these two PDF. So the multiplication of height of these two PDF is 1 by 4 and 1 by 2. If I multiply these two, so I will get 1 by 8. So that will become slope of this trapezoid. So for that, if this is the slope, so slope is nothing but height divided by base. So what is the value of height? So this height would become, because the base is 2, so if you multiply with the 2, so the height will be 1 by 4. Okay, so to get the value of height, you have to multiply it with base. So the slope is 1 by 8 and you have to multiply it by the base, that is 2. So the height will become 1 by 4. Now in this question, we have to calculate the probability that z greater than equal to 0. It is nothing but the area under 0 to infinity f z of z dz. So this will be from 0 to 2 f z of z dz. F z of z dz, that means area under this part. So what is the area under this part? So area is 1 by 2, base is 2, height is 1 by 4, you will get 1 by 4. So that means probability z greater than 0 is 1 by 4, and according to the option, the correct answer is option D. Okay. So let's solve next question, question number 8. So there are other students, those who are now, if you are joining now, then you can watch the questions later on, and let's come to this question which is showing on your screen. So the question is, the autocorrelation of a wide sense stationary random process is given by e to the power -2 mod tau. The peak value of spectral density is, this is the property that Rxx0 should be greater than equal to Rxx of tau. Okay. So we also know that question number 8. We also know that the autocorrelation function and power spectral density are Fourier transform pair. Okay. So e to the power minus 2 mod tau is its Fourier transform. What is the Fourier transform of this? This is nothing but 2a upon a square plus omega square. Okay. So this is a is 2 here, this is e to the power minus a mod tau. Okay. So if you compare, you will get the value of a as 2. So this is 2 into 2 and 2 square plus omega square. So you will get 4 upon 4 plus omega square. So this is the value of Sx of omega, which is the power spectral density of this function. Power spectral density. So what is the value, peak value? So you will get the peak value at omega equal to 0, which is 1. Because if you substitute the value of omega other than 0, you will get the value less than 1. Because if I substitute omega equal to 1 or minus 1, I will be having 4 upon 5. So the value will be less than 1. So we have to calculate the peak value of this, and the peak value of this is, we will get at omega equal to 0. So that is 1. So the correct answer is option B. Okay. We have to calculate the peak value of power spectral density. Okay. So the power spectral density is Rx of 0 is greater, and Rx of 0 is nothing but the power. Okay. And the power is, we will get at tau equal to 0. So if I substitute tau equal to 0, then also I will get 1. And this is the other way of looking this question. Okay. So now let's move to the next question. Question number 9. Question number 9. So question number 9 is, a random variable x is called symmetrical about 0 for all x employs the real, and probability of x greater than equal to x and probability of x less than equal to minus x. The PDF of x where x is symmetrical about 0, the probability that mod of x less than equal to x is. So are you solving or not? Please reply me. How many of you are solving? Ketan and Vishwanathan, only 2 students I am getting, and Abhishek, only 3 students. So what others students are doing? If you are not solving, if you are not learning, that is the waste of your time. Okay. So you should learn from everywhere. If you are not coming, then this will not be going to help you. If you are not solving, Manku, are you solving or not? That is not important, that how much time I am going to take. So question number 9 is probability that x greater than equal to x is equal to probability that x less than equal to minus x. It is given, we know that the CDF is defined as probability that x less than equal to x. Now if I want to write this, that can be written as probability that x greater than equal to x can be written as 1 minus probability that x less than equal to x. Okay. So from here what I can write is 1 minus fx of x equal to fx of minus x. So this will be the result from this particular equation with the help of these two. Okay. Fx of x is defined as probability that x less than equal to x. So we are having x less than minus x. So I can write fx of minus x, and x greater than x, if it is written, then x greater than x can be written as 1 minus probability of x less than equal to x, and this part can be written as fx of x. So including these two equations, I can get this result 1 minus fx of x equal to fx of minus x. So what we have to calculate in this question is probability that mod of x less than equal to small x. So what does it mean? So it means that the random variable x takes value greater than equal to minus x and less than equal to x. So you can also write it as from the property that we have already seen in the previous question. If there is a range of the probability and you have to calculate it by the CDF, so that is fx of x, that is the extreme value minus of the previous value, so fx of minus x. Now fx of x minus fx of minus x, we can write fx of minus x, I can write 1 minus fx of x, so 1 minus fx of x. So if you solve this, you will get 2 times fx of x minus 1. So according to the option, the correct answer would be option C. Abhishek, this would be the way to solve this question. Option C would be the correct one. Okay, Abhishek, are you getting the point? So this is the basic definition of CDF, and this is the property of CDF. The property of the CDF is, if you want to calculate the probability between the two values, so that is the value of the CDF at the highest point minus minimum point. Okay. Okay, no problem. Solve carefully, you will get the answer. I am sure that you are having the good concept about the random variable and random process. Now next, solve question number 10. Question number 10, there is another concept of a random process, or the property of the power spectral density, or you can say the autocorrelation. Question number 10 is, consider a low pass random process with a white noise power spectral density n by 2 for minus b to b. The autocorrelation function Rx of tau is. So we have to calculate the autocorrelation, and the power spectral is given. So solve this question. That is a very basic question, and you should be familiar with the power spectral density of this type of signal. Then you will get answer very soon. answer is getting is B. Vishwanathan, are you sure? You can check your answer till others answers. Option C. Anybody else? Why you are taking so much time to solve this type of question? Because this is the standard signal, and you should be able to write the Fourier transform of this type of signal very soon. Now the question number 10 is, here is again the property that Rx of tau, the Fourier transform of autocorrelation, is nothing but power spectral density. This is Wiener-Khinchin relationship. Okay, so here we are having the signal, suppose a rectangular T upon, I should write in the terms of tau because this is tau upon T. So if the signals are given in the rectangular form, its Fourier transform is nothing but AT sync of F and T. Okay, so AT sync of, now if I apply the duality property here, this F is replaced by tau T, the Fourier transform would be a rectangular that is replaced by minus F upon T, and the rectangular function is an even function, so this is rect F upon T. Now because in the question we are having this power spectral density, and this power spectral density is given as n by 2 for the range minus B to B. So this Sx of F is given, so these two are same. So if I compare, I will get the value of A, which is the height of the rectangular pulse, and capital T, which is the width of this rectangular pulse, as to B. So if I substitute the value here, I will get n by 2, this is n by 2 into T, which is 2B, and sync of tau into T, T is 2B here. So we will get 2 and 2 get cancelled, and we get NB sync of 2 tau B. Its Fourier transform will be this. Its Fourier transform will be this rectangular pulse. Is it okay? So NB sync 2B tau, and according to the option, the correct answer is option C. Okay. So Ketan, why you are saying option D? None of the above, not, you are getting the answer here. So the correct answer is option C. Now next is, let's move to the next question. You can check it later on. Question number 11. Question number 11 is, consider the random process x of t is equal to u plus vt, where u is a Gaussian random variable with u 2, 4, and v is a random variable uniformly distributed between 0 and 2. So assume that u and v are statistically independent. The mean value of random process at t is equal to 2 is. Consider the random process x of t is equal to u plus vt. At t equal to 2, you have to calculate the mean value. .76. First answer I am getting 5.76. Width of the rectangular pulse was 2b in that question. Okay, no problem. You are learning here, so this type of mistake can be considerable, but you have to be very much careful in the exam. So if you are doing mistake here, then it is okay, but you should not do the mistake in the exam. Abhishek is getting 4. So 5.76 and 4, two different answers I am having. Which one is correct, or any other answer is correct? Manish is getting 6. Manish has joined again. I think Manish, you have gone somewhere else, because you are not participating in the questions, but in this question you are coming back. Okay, so let's solve this question, question number 11. So question number 11, we are having x of t is equal to u plus vt. Okay, u plus vt, not a function of t, this is multiplied with t. So we have to calculate the mean value at t equal to 2. So at t equal to 2, what is this random process? Actually the random process will become random variable, because the sampling of random process is random variable. So this is u plus 2v. Okay, now we have to calculate the mean value of this x of 2, or you can say the mean value of u plus 2v. So the mean value of u plus 2v, we can apply it in the individual term. So you will get expected value of u plus 2 times of expected value of v. So what is the expectation of u? Expectation of u, because it is given that u is a Gaussian random variable with 2, 4. What does it mean? So it means that this is the value of its mean and this is the value of its variance. Okay, so the mean value of this Gaussian random variable is 2 and the variance is 4. So we have to put the value of mean only. We required only the mean value of u, so that is 2. Okay, and now the mean value of v. What is the v? So v is uniformly distributed function between 0 to 2. So this is the minimum value, which is 0, and the maximum value is 2. We know that the mean value v bar is given as, this is u bar and this is sigma u square, and the value of v bar, that is the mean value of v, is for a uniformly distributed random variable, it is equal to a plus b by 2. So this is 1 average value. So this value is 2 and the mean value of v is 1. So this is nothing but 4. So 6, 4 and 5.76 I was getting. So these different answers we were getting, but as you can see, that is the very simple question, and you have to know that if the Gaussian random variable is given in this form, the first value is its mean and the second value is its variance. So you should not do any mistake in the calculation. That is the very simple calculation. I don't know where you did the mistake. Now coming to the next question, question number 12. Consider a random process x of t equal to 3vt minus 8, where v of t is a stationary random process with autocorrelation 25 plus 4 upon 1 plus 6 tau square. The power in x of t is. So all of you have joined the Telegram group. If you have not joined, then please join that group to connect with me for communication and AMT. I can directly will be in touch with you with the help of that particular group. And there is a separate group for Signal also, so you can join that group also, and that Neeraj sir have told already. So any answers that you are getting? Consider a random process x of t equal to 3 Vt minus 8, where Vt is a stationary random process with autocorrelation given as 25 plus 4 upon 1 plus 6 tau square. That is for the autocorrelation of V, 295. First answer I am getting as 295. Check your calculation, Abhishek, once. I am waiting. I think there is a calculation mistake. Check once. $261. Vaibhav, you also check your calculation. I don't think this is the right answer. So let me solve this question. Question number 12. We have to calculate the power. Power in xt is nothing but mean square value. Mean square value of xt. Power in xt is equal to mean square value of xt. Okay. So expected value of x square t we have to calculate. So expected value of x square t is expected value of x square. X square, if I do, this is the 3 Vt minus 8 whole square. And this is equal to 9 expected value of V square t, okay, plus expected value of 64 minus 48 into expected value of Vt. So expected value of Vt, that means the mean square value of Vt, and the mean square value of Vt you can calculate Rv tau. This is 25 plus 4 upon 1 plus 6 tau square, and expected value of V square t, that means the mean square value we get at tau equal to 0. So if I substitute tau equal to 0, I will get 29. And this is the mean value of Vt, and we get the mean value of Vt from the autocorrelation if tau tends to infinity. And if the tau tends to infinity, this will be 1 upon infinity, it is equal to 0. So this is the mean square whole square. Mean value of Vt whole square, we get limit t tends to infinity, tau tends to infinity, Rv tau. So we get 25. So here we get 5 only. So expected value of Vt is 5. I think you guys are also doing the same thing. The expected value of Vt square is limit t tends to infinity, Rv tau equal to 25. So the mean value is 5, not 25. So I think you are doing this mistake. If you are taking the 25, you may get the answer as I was getting 261 and 295. But this is not the property. The property is the mean whole square equal to limit t tends to infinity. So here we require only mean value, not the mean whole square. So you have to take the root over it, and you will get the mean value, which is 5. So now you will substitute the values. So you will get 9 into V square. What is that V square? This is 29 plus 64 minus 48 into 5. Okay. So after solving this, you should get the answer as 85. Okay. Now you guys are getting the correct answer. Okay. So what mistake you were doing? Can you tell me what was the mistake? Because if I solve the question later on, I can tell the students what are the different mistakes that the different students can do. So you were getting the 295 and 261. So why you were getting the different answer? Can you tell me? Okay, no problem. No problem. We can move to the next question. Question number 13. Let's solve the question number 13. X of t is a random process with a constant mean value of 0 and the autocorrelation Rx of tau 4 times of e to the power minus 0.2 mod tau plus 1. Let x be the Gaussian random variable obtained by sampling at t is equal to ti and x let q of alpha is given. The probability that x less than equal to 1 is. Multiplexing topic in communication theory. I will cover, but you have to take some time. Okay, a plus b square. Okay, a plus b whole square. Good. This type of mistake cannot be done, right? This is the very basic formula, so you cannot do. We cannot accept this type of mistake, right, Abhishek? No problem if you are doing so, but that is really funny. Let's solve question number 13. Probability that x less than equal to 1. Hi Shiva, you are coming very late now because we are going to end this session, but you are having the 3 questions, and the first question you can see in your screen. You can solve the last 3 questions, 13, 14 and 15 we are going to solve. So in this question it is given that the random variable is Gaussian. So probability that x less than equal to x is written as fx of x, and if the x is Gaussian, if this x is Gaussian random variable, then fx of x can be written as fx of x minus x bar divided by sigma x. If x is Gaussian random variable, then the probability is given as fx of x equal to x minus x bar divided by sigma x. So here we have to calculate for x less than equal to 1. So this is equal to fx of 1 minus x bar divided by sigma x. So you have to calculate the value of mean and the variance. So the value of mean is given as 0. So x bar is given as 0, and we know that the variance equal to mean square value minus mean whole square. So the mean square value is 0. So the variance equal to mean square value. And what is the mean square value? Mean square value is the autocorrelation at tau equal to 0. Autocorrelation of x is given at tau equal to 0. This will be 8. This will be 8. So the variance is 8. So we have to write sigma x, not sigma x square. So you have to take the root over it. So we will get 2 root 2. So the sigma x is 2 root 2, and if I substitute the values here, so this is 1 minus 0 upon 2 root 2. There is one mistake that I have done. This fx of x is actually 1 minus q times of this one. So one thing I left, actually this is what I should write, is 1 minus q of this. Okay. So 1 minus q of 1 upon 2 root 2. Okay. If the x is Gaussian random variable, then the CDF is given as 1 minus q of x minus x bar divided by sigma s. Yes, Abhishek, I also did the same thing what you did, because the same calculation mistake I did. I had not written this value because of hurry, because now we are having very less time and we have to solve the 2 questions. So yes, it happens. There is no big issue. We are confident that we are having the good concept. So Abhishek, Ketan, you are getting Q 0.5. So you can see that how to solve this type of question. Okay. So next question is question number 14. Let x of t be a wide sense stationary random process with the power spectral density. Question number 14 is a white noise x of t with two-sided power spectral density 1 into 10 to the power minus 10 watt per hertz is input to a filter whose magnitude square response is shown. Then the power of the output process y of t is given by. Another wrong answer by Abhishek. Now you should not delete it. You should correct it, right? Why you are in so much hurry? You can take sufficient time. So this is a very simple question, and the power spectral density of output is h of f, that is the magnitude square response, and the input power spectral density. And because it is given that the power spectral density of input is constant, which is 1 into 10 to the power minus 10, 1 into 10 to the power minus 10. So the input is having the power spectral density like this, and the magnitude square response is given as magnitude square response is minus 5 to 5, and it is in kilohertz. And this is h of f magnitude square. So the output power spectral density would be, when we multiply these two, these two equations are multiplied. So if you multiply this with this, you will get the output power spectral density. So at f equal to 0, we are having 1 into 10 to the power minus 10, and here at f equal to 0, we are having the value as 1. So it is 10 to the power minus 10, and it is minus 5 and 5. It is actually not written in the diagram. It should be at f equal to 0, it should be 1, and that is understandable, because in general we generally have the magnitude response as 1. So the power we have to calculate. So the power is nothing but the area under power spectral density. So power is nothing but area under power spectral density. So what is this area? So 1 by 2, base is 10, and that is in kilohertz. This is in kilohertz, right? And the height is 10 to the power minus 10. So you will get 0.5 into 10 to the power minus 6, or you can write 0.5 into 5 into 10 to the power minus 7. So that is option A. So the correct answer would be option A. So many of you are getting option B, but check your answer. The correct answer should be option A. D is for previous one. Okay. Okay, so one last question. Question number 15. Solve this question quickly. So we are having the next session also from 8 p.m. Next session most probably in Monday. Next session on communication will be on Monday. Sir, please come live at or after 7. We can be more productive. See, there are many live sessions going on. So in the 8 p.m. we are having the session of aptitude, and at 10 p.m. we are having this live session of signal. So we are having actually 3 sessions in a single day. So one has to come in about 5 p.m. or 6 p.m. So I took that slot. So you can watch it later also, but if you come live, then you can interact with me. That is the beneficial and the benefit of coming live. But you can, if you are not able to come, then you can watch it later on. Okay, Vishwanathan, are you getting? Because you know that there is another session from 8 p.m. Kulkarni, Ketan, the book name is Microwave Engineering is for Kulkarni for ESE. Well, I am going to cover this microwave and radar for ESE in my pen drive course, but and if you want to take separately, then you can buy it, and I will cover few topics in the live session or by the video recording. So we are having the question number 15. Let x of t be a wide sense stationary random process with power spectral density as shown, and the same concept we can apply because the filter is given here. So as you can see from the diagram, there is a low pass filter. This is a low pass filter and having a cutoff frequency of 1 Hertz, and at the input we are having the power spectral density Sx of f, which is given, and Sy of f. We have to calculate the mean square value. The mean square value, that means the power, and the power is nothing but the area, okay, area under power spectral density. So for that we have to calculate Sy of f. So Sy of f is xs of f and h of f mod square. So if you multiply, this is your power spectral density of input, and this is the low pass filter having a cutoff frequency 1. This is h of f and the magnitude is 1. So when you multiply these two, you will get the power spectral density at output, which can be drawn as shown in figure. This is 1, minus 1 and f. So power is nothing but area, and how do we calculate the area? So we can calculate the area by integrating from minus 1 to 1 Sy of f df, and if I, because this is an even function, I can write 2 times of 0 to 1, and power spectral density is always an even function. So 2 times 0 to 1 Sy of f, so it is e to the power minus f df, because it is defined as e to the power minus f here, and it is e to the power f for the negative side. So e to the power minus f df. So when you solve this, you will get the answer as 2 times e to the power minus f divided by minus 1, 0 to 1, and if you solve 1 minus e to the power minus 1, and the value you will get as 1.65, 1.264, 1.264. Okay. So these are the 15 questions for today's session, and in the next session we will cover the amplitude modulation. Okay. So I hope this session will be beneficial for you, and you have revised the throughout the random variable and random process. So in the next session we will solve the more questions from the amplitude modulation, and remember that I am covering the whole chapter one by one, and then I will come back to the random variable and random process again, because once you will go through all the chapters, and then we will come back to the random variable, and that will be the cyclic revision for you guys. Okay. So thank you, Ketan, and I hope you all have enjoyed, and please join that Telegram group. That will be very much beneficial for you. Okay. Thank you.